All right, this is the 2016 10A problem number 6. I really encourage you guys to listen to the whole videos because a lot of times I'll drop like structure of thought kind of thing, strategies in the middle, not just about the problem itself, but about approaching the test and kind of strategic approaches to taking these kinds of tests. Zamina lists the whole numbers 1 through 30 once. Emilio copies Zamina's numbers, I don't know if you're saying the name right, whatever, replacing each occurrence of the digit 2 by the digit 1. Zamina adds her numbers and Emilio adds his numbers. How much larger is Zamina's sum than Emilio's? Again, he took all of her 2's and turned them into 1's. Now, as is always the case, there's going to be a fast approach and a slow approach. Your goal is to spend at least 10 to 20 seconds seeing if you can come up with the fast approach plan. The slow approach, what would it look like? Your fallback plan, that is if you cannot figure it out, you just write the numbers 1 through 30 out and do it that way. Are you going to lose about 2 to 3 minutes of time? Yeah, you are, but it's better to get it right than not get it at all. On some situations, depending on where you're at in the test, you should skip that problem if you can't think of the fast way and return to it later when you've exhausted known problems that you can get through quickly. Okay? But you know you can do this, so if you get like 5 minutes left and there's like number 23 versus this one, probably come back and do this one if it's fast or not that long to figure out compared to 23. Okay, so the long way, we don't want to do it that way. That's tedious. That's a waste of time. We got to think about how we can do it smarter. Well, let's think. On the way to 30, how many times will 2, if I just the normal count, how many times will it appear in the ones place, the units digit, if you will? Well, it'll happen at 0, 2, 12, and 22. Don't worry about this 2 right now. Just ignore it. These are the 3 places it happens in the ones place. If you're going to change all those into ones, you're going to lose a total value of 3 for that. Again, we'll handle the 2's in the tens place separately. Now, how many times does 2 appear in the tens place? It happens every time from 20 to 29. Again, don't think that that's 9 times. It's b minus a plus 1. It's 10 times. There's 10 numbers in the 20s after all. It makes sense. So it's going to happen 10 times, and each time I do that, right, 29 becomes 19, for instance. How much do I lose? I lose 10 because it's in the tens place. And it happens 10 times, so that's 100, and the answer is 103. Okay, and now for problem number 7 of the 10A from 2016. The mean, median, and mode of the 7 data values. Again, there shows 7. Don't really read them in your mind. It's not going to do you any good to read them. Just go, okay, those values, because you're not going to learn anything from it. Are all equal to x. What is the value of x? Again, spend 5 seconds making a strategy. If we put them in order from left to right, that might tell us about where the median is located, but it probably won't give us the answer. The mode, that's not going to help us right now. Probably we should target the mean. The mean is simple. It means the average. You add everything up and divide it by the number of values, and that has to equal the average. Now, when you go to add these, probably don't write them on paper or anything like that. They're already written on your paper. And don't just add left to right, this plus this. Rather, add the values that work well together, like 60 and 40 is 100, plus another 100 is 200, plus 200 is 400, and 140 with the last one. Add them in your mind. 90 and 50 is 140, so 400 and 140 is 540 plus x divided by 7, but okay, the way it works for average, it's like sum of 7 things divided by 7 equals x. What do you do at this point? You multiply by 7. So if you're thinking that in your mind, instead of writing divided by 7 right here, just multiply it up to what you're going to write. You're going to say that the average is x. So then it's equal to 7x, 6x, x is 90, right? You're going to divide by 6 immediately to get 90 as an answer. Now, again, if we went a little fast, we can go a little faster than this even. If you went a little fast, you probably should second guess yourself. Is there any way I could have made a mistake? Because we don't want to make mistakes. Maybe quickly, either mentally or on your paper, you can see this in your mind, 40, 50, 60, 90, x could go here or here, right? So if I put the x in between, you can see that it makes sense that this is in fact the median because you also have 100 and 200. and it does have to equal one of the values, it makes sense that it's 90. Now, if we had started with the median concept, we wouldn't know whether x was 60 or 90, but we would know it was one of those two. Unfortunately, they both appear in the answers, and so it wouldn't do us any good to just know that it's either 60 or 90. We're still going to have to do this process to get the answer correct. Okay, here we are, moving on to problem number 8 from the 2016 10A. Trickster Rabbit agrees with Foolish Fox to double Fox's money. Again, you might want to underline things as you go every time Fox crosses the bridge to Rabbit's house. So Fox is going to Rabbit's house, Rabbit doubles his money as long as Fox pays 40 coins in total to Rabbit after each crossing, right? So let's just kind of make sense of this. Fox could start with x, it would get doubled, and then it would lose 40 to become 2x minus 40, right? This is how the process works, okay? This is one payment. Let's keep going. The payment is made after doubling, so it gets doubled first, and then he loses 40 coins back to Trickster Rabbit. Fox is excited about his good fortune until he discovers that all his money is gone after crossing the bridge 3 times. How many coins did Fox have at the beginning? In other words, this x over here. And there's 2 ways we can approach this, and we will try both. Okay? So, what we can do is use this algebraically first. Okay? So if I double and then I lose 40, this is where he's at after one payment. Then he's going to get his money doubled again. 4x minus 80. Then he's going to lose 40. 4x minus 120. That's now his second payment. Then he's going to double his money again. 8x minus 240. And he's going to lose 40. 8x minus 280. Right? This is the third payment, and now all of his money is gone. So it must mean if it's all gone, he has 0. So 8x must equal 280, and 8 goes into 240 30 times, and 8 goes into 40, which is the gap, right? The gap between 240 and 280 is 40. 8 goes into that gap 5 times. So x is going to equal 35, which is indeed the answer. The other way we could have done it, maybe you don't like algebraic equations and you don't want to write this all out. You could think, how much money did Fox have when he crossed the bridge the third time? Well, he must have had 40 at the end of crossing the bridge and then given that money to Rabbit right afterwards to have 0. So he must have crossed the bridge with 20. Okay, we can work backwards from there. This is the third crossing, right? He crosses, gets 40, and then immediately pays it to have 0. So what would have happened right before this, before he crossed the bridge? He would have just finished paying Rabbit 40, so he would have 60. That means he must have started walking across with 30 because he got doubled to 60 and then subtracted 40. So this is right before he crosses the bridge, after he crosses, and then makes payment. So this would have been the second crossing right here, right before he crossed it. Let's go backwards again. What just happened right before he crossed the bridge? He had just finished paying Rabbit 40 coins, which means he must have had 70, and you're going to double something to get to 70. That's going to be 35. We get it both ways. And here we are on problem 9 of the 10A from 2016. A triangular array of 2016 coins has 1 coin up in the first row. So you've got 1 coin and 2 coins in the second row, 3 coins in the third row. That's why they're triangular. In fact, if we add the numbers in these rows, it's 1 plus 2 plus 3, and it keeps going for each row. That's why these numbers are called the triangular numbers. You can look that up to find other problems that deal with triangular number. Okay. So 3 coins in the third row and so on up to n coins in the nth row. What is the sum of the digits of n? It's good to memorize the sum of the triangular numbers up to the nth value. It's simply equal to n times n plus 1 over 2. What if you couldn't memorize that? Well, sad day, you should memorize it. But if you can't remember it, you can just think of this being an arithmetic sequence. Or series rather. So for an arithmetic series, it's the average of the first and last n plus 1 over 2 times the number of terms n. Well, these expressions are equivalent, right? The other thing that you could possibly do, let's say you didn't know that one either, right? The average of the first and last times the number, the number of digits in the sequence, right? In the series. Then the other way that you could do it is you could use the sum formula. The sum of the first n arithmetic terms of a sequence is a sub 1 plus a sub n over 2, again, times n, where n represents the number of terms in the series, the sum that you're doing, right? And you can see that this is the same thing, the sum of the first and the last, a sub n being the nth term. So you could have this thought, you could have this thought, you could have this thought. You could even use Gaussian. Gaussian, again, is the concept. Let's say you need to add the numbers 4, 5, 6, 7, 8, and 9. You can take 1 and 9 to make 10, 10, 10, and 10, and then add 5 to get 45. That's the Gaussian method. I mean, he cleans it up a little more than that for large number sets, but the essential idea is that the first and last make the same as the second and second to last, third and third to last, and so on. Okay, so all of those things are applicable. The fastest one, of course, is just to know that this is the sum of the first n triangular numbers. So here we go, moving on from that concept. N times n plus 1 over 2, this is the total of all the numbers there, and there is 2016 coins in this triangular number set. Simply multiply by 2 to get 4032. Now, for the ending of this problem, you could distribute, move this over, and try and factor, but that sounds like as much fun as punching yourself in the throat. So let's not do that. This is pretty close to a perfect square. Let's think about a perfect square nearby. Let's do 60 times 60, and you would get 3600. Or a little low. Let's go to 65. 65 squared, using the fives trick that we talk about in other videos. You can ask about it in comments if you don't know. It's 6 times 7, the number after 6 in the number line, which is 42, and then 5 squared added to the end, 25. So 65 squared is 4225. That's really close, and it's a little bit over, so it's less than that, and we need it to end in 2. Taking advantage of units digit properties, we know that a 3 times a 4 will give a units digit of 2. Therefore, we know this is 63 times 64 must equal that. 3 times 4 giving the 2. N is 63. It doesn't ask for n. It's a good thing it's not up there. What is the sum of the digits of n? Since n is 63, 6 plus 3 is 9. Now, because we use some kind of gimmicky or speed tricks at the end, maybe we should just check it. If you were doing it on the test, it's not that hard to multiply this out. So you could do, 63, just check it on your own. We're not going to do it on the board now, but if you had to, right? Okay. All right, the last problem of this set, the 2016 10A, problem number 10. A rug is made with 3 different colors as shown. I don't have different colored markers on me, so we're just going to have to pretend. This is white. This part here, the next rectangular kind of portion outside of it, is light gray. And the outside rectangular region, like it's not a rectangle, but the outside ring kind of thing, is kind of a darker color, like dark gray or blackish. Okay, so just pretend that those values are there, those colors are there. So 3 different colored regions. Okay. The areas of the differently colored regions form an arithmetic progression. The inner rectangle is 1 foot wide, and each of the 2 shaded regions is 1 foot wide on all 4 sides. What that means is this is 1 foot, that's the inner rectangle, right? What is the length in feet? So the length is this part, we can call it x. We don't know what it is, call it x. You don't know, put a variable in, and x is the most common. It also said that this width between here and here is 1, right? Is 1 foot wide on all 4 sides. And this is 1 foot between here and here, right? And all of these are 1 foot distances. Obviously, the scale, it's not drawn to scale, the drawing, okay? So I'm going to go through as if I was making a mistake, and we'll see if you can pick up on it. Okay, so it said it makes an arithmetic progression. So the area of this first rectangle is x. If I move out, x plus 1 here and 1 here is x plus 2, and I add 1 here and 1 here, and this width is 3. So 3 times x plus 2, that's the second rectangle's area. And the last one is I add 1 and add 1 to get x plus 4. And I'm going to multiply that, because that's this length here, times this, which is the 3 from here plus 1, which is times 5. Now, this is supposed to be an arithmetic progression, right? So x, 3x plus 6, and 5x plus 20. Now, arithmetic progressions mean they have a common difference. So if I take this and subtract this, I get 2x plus 6, and this minus this is 2x plus 14. Subtract the 2x's and 6 equals 14. Well, what did we do wrong? Hopefully you were thinking about it and already recognized the mistake that I was intentionally making to represent a mistake that a student might make on the test. Don't freak out when stuff like that happens. It's actually good. It means you get to know that you made a mistake before you circle one of the false answers. Just figure out what it was. Go back and read carefully. It says the areas of the 3 differently colored regions. Now we substituted in our mind the whole rectangle, but actually it's this part right here. That's the area we're looking for, and the standard way to do that is the outer rectangle minus the inner rectangle. So it is kind of similar. These are the areas of the rectangles, but not the ring areas, not the shaded regions in the original problem. So we still take this and subtract this to get this area here. Now the first area is x for that white area, and then the darker area, the ring around outside of it, is the outer rectangle, the middle rectangle minus the inner rectangle. That area is only 2x plus 6. Okay? And lastly, then this last outer ring, if you will, is the 5x plus 20 minus the inner rectangle that's part white and part shaded. That's going to give 2x plus 14. So these are the areas of the shaded regions, which is what it said. It didn't say the rectangles. So now we do the arithmetic progression. This minus this is x plus 6, and this minus this is 8, and x will equal 2. Now let's say we still felt a little uncomfortable. What could you do to, again, achieve that feeling of guaranteed rightness? Simply plug it in now and check and see if it works. If I plug 2 into this x, I get a rectangle area of 2. Right? We can then add from 2 times 1 was 2. 2 added out is 4, times 3 is 12. 12 minus 2, the inner rectangle, is 10. Right? This is 12 minus 2. 12 is this outer rectangle, and 2 is the inner rectangle. So this shaded ring again is 10. Now do it again. Again, this was 2, this is 4, this is 6, because we're adding 1 on each side, right? So then you're going to get 6 times the width here of 5, but that's 6 times 5 minus the inner rectangle of 10. Oh, not 10, of 12, yeah. So 30 minus 12. Took me a second. Okay, so you get 2, 10, and 30 minus 12 is 18. Plus 8 plus 8, we confirm it's arithmetic. I almost made a mistake there, but I'm not going to change the whole video just for that. Okay, that's it for this set. We'll see you in the next set.